Hi students, today first chapter real numbers. Already I taught you polynomials, second chapter, third chapter linear equations in two variables. Next quadratic equation. Already three chapters are over. This is the first chapter real numbers. Now first introduction. In introduction you will have classification of numbers. Next basic concepts. In basic concepts I will tell you what is multiple, factor, LCM, HCF and perfect number, co-primes, twin primes and LCM and also HCF. LCM means least common multiple. HCF means highest common factor. Next, fundamental theorem of arithmetic. In this also we will do some problems on LCM and HCF, and this is nothing but prime factorization. Next, Euclid's division lemma, Euclid's division algorithm. Next, rational numbers. In rational numbers, you know terminating decimals and non-terminating decimal expansion. Next, and also irrational numbers. Next, logarithms. In some states, they have introduced logarithms. Next, part B will be solved problems. Very short questions and essay questions. Part C, IIT Foundation and Olympia problems. Next, part D will be practice questions and objective questions. In introduction, classification of numbers. You have already learnt about numbers system, natural numbers, whole numbers, integers, real numbers and rational numbers. All these numbers you know in lower classes. First, I would like to ask you questions. How many books I have? I have one book. Now, how many books I have? I have two books. How many books I have? I have three books. How many books I have? I have four books. How many books I have now? Five books. We can count the objects, books, articles, anything. Counting of objects are represented by 1, 2, 3, 4, 5, 6, 7, 8 and so on. We have infinite numbers. We cannot count the numbers. These numbers are called natural numbers. How can you represent natural numbers on a number line? 1, 2, 3, 4, 5, 6 goes on like that. Next, 1, 2, 3, 4, 5, 6, 7, 8 and so on. They are called natural numbers. Next, how many books I have? I have no books. It is represented by 0, 0, 1, 2, 3, 4. These are called whole numbers and it is represented by, whole numbers are represented by W. How can you represent whole numbers on a number line? See, 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. Natural numbers are represented by 1, 2, 3, 4, 5, 6 on a number line like this, and whole numbers, natural numbers and 0, they are called whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8 like this, they are called whole numbers. How can you represent temperature? Temperature in centigrade degrees. See, 0, 1 degree, 2, 3, 4, 5, 6, 22, 35, 100, 5500, 15 into 10 to the power of 6. 0, -1, -2 degrees, -3 degrees, -4 degrees centigrade, -12 degrees. It goes like this. At 0 degrees centigrade, water converts to ice. 0 degrees centigrade. See, what is the temperature in the night? Yesterday's temperature is 22 degrees centigrade in the night. What is the day temperature? 20 degrees centigrade. And what is the day temperature? 35 degrees centigrade. What is the 100 degrees centigrade? Boiling point of water is 100 degrees centigrade. What is 5500 degrees centigrade? What is it? sun's surface, temperature on sun's surface is 5500 degrees centigrade. What is the temperature inside the sun? The temperature inside the sun will be 15 into 10 to the power of 6 degrees centigrade inside. It is very hot. 0 degrees, minus 1 degree centigrade, minus 2 degrees, minus 3 degrees, minus 4 degrees, and it goes like this. At minus 4 degrees centigrade, temperature in Kashmir. What is the temperature in Kashmir in winter? It is more than minus 4 degrees centigrade. What is the temperature in Ladakh? It is more than minus 12 degrees centigrade. What is the hottest day temperature on earth? It will be 55 degrees centigrade at Death Valley. In USA, North America, the Death Valley will be the hottest place on the earth. Now, how can you represent this temperature on number line? You can represent like this: 0, 1, 2, 3, 4, like this, minus 1, minus 2, minus 3, minus 4. These are called integers. You see, these are called integers denoted by Z. Integers are denoted by Z. See, 0, 1, 2, 3. These are whole numbers. And 1, 2, 3, 4. These are called natural numbers. And these are called negative integers. They are represented by Z minus. Next we will go to rational numbers. This is one page. I divided this page into two parts. How can you represent this part? This part will be 1 by 2. And this is 1 by 2 and this is 1 by 2. Two 1 by 2's make 1. I will divide this page into three parts. I divided this page into three parts. 1, 2, 3. How can you represent this part? This part is 1 by 3 and 1 by 3, 1 by 3 and 1 by 3. This is 2 by 3. This is the 1 by 3 plus 1 by 3, 2 by 3. I want to divide this page into four parts. 1 by 2 plus 1 by 2. 2 halves make 1 and I will divide. How can you represent this part? 1 by 4. 1 by 4, 1 by 4, 1 by 4, 1 by 4. This part will be 1 by 4. This 1 by 4 plus 1 by 4, 2 by 4. 2 by 4 is nothing but 2 by 4. 1 by 4 plus 1 by 4. 2 by 4 is nothing but 1 by 2. 1 by 4 plus 1 by 4 plus 1 by 4. It is 3 by 4. As these are rational numbers. These are rational numbers. See, this 1 by 2 also represented by 0.5. 0.5. 0.5 is nothing but 5 by 10. 5 ones are 5 twos are. 1.1, 1.2, 1.3 or 2.5, 3.6, 7.9 are also they are rational numbers. How can you rational numbers? 11 by 10, 12 by 10, 13 by 10 and 25 by 10 and 36 by 10 and 79 by 10. These are also rational numbers. What is a rational number? A rational number is in the form of P by Q. Q is not equal to 0. P and Q are integers. See, I will write the definition of rational number. What is a rational number? It is represented by Q. See, what is a rational number? Rational number, it is represented by Q. It is in the form of P by Q, Q is not equal to 0. Denominator should not be equal to 0. And where P and Q are integers. You see, you observe all, you see the denominators, they are not equal to 0. PQ means 11 and 10 are integers, 12 and 10 are integers, 1 and 2 are integers, 1 and 3 are integers, 2 and 3 are integers. You observe all these, they are rational numbers. You have a doubt, sir, whether 0 a rational number? As 0 can be written as 0 by 1 is a belong to rational number, because Q is not equal to 0. P and Q are integers. 1 is not equal to 0 and 0 and 1 belong to rational numbers, as 0 by 1 is a rational number. You have a doubt whether 1 by 0 a rational number or not. It is not a rational number. It cannot be defined. Q is equal to 0. Here you see, it cannot be defined, undefined. It is not a, it does not belong to a rational number, because Q should not be equal to 0, but here Q is equal to 0. That's why 1 by 0 is undefined. It does not belong to a rational number. How can you represent a rational number on number line? Now, how can you represent 1 by 2 on number line? 0, this is 1. It is 1 means 1 by 2 means I will divide this into two parts. This is 1 by 2 and this is 1 by 2. 1 by 2 plus 1 by 2. This part will be 1 by 2. 1 by 2 plus 1 by 2 make 1. 1 by 2 plus 1 by 2 is equal to 1. How many 1 by 2's make 1? 2 1 by 2's. How can you represent 1 by 3 on number line? I will divide this line into three parts. We have to divide. I have divided the paper into three parts. Like that, we have to divide this number line into three parts. 1, 2, 3. This is 1. This is 1 by 3, 1 by 3, 1 by 3. How many 1 by 3's make 1? 3 1 by 3's. 1 by 3 plus 1 by 3 plus 1 by 3 is equal to 1. How can you represent 2 by 3 on number line? Again, you have to divide this 1 into three parts. 1 by 3 and 1 by 3 and 1 by 3. 1 by 3 plus 1 by 3, 2 by 3. This is 2 by 3 part. And this will be 3 by 3. 3 by 3 is nothing but 1. 2 by 3 is represented on number line like this. How can you represent 5 by 8 on number line? 5 by 8 means 1, 2, 3, 4, 5, 6, 7, 8. We have to make it into 8 parts. I am dividing 29 with 6. 6 4s are 24. You are getting 5. 5 by 6. You have to start from 4. 1. You have to make into 6 parts. 1, 2, 3, 4, 5, 6. This is 5. This will be 4 plus 5 by 6. Up to this is 4. This will be 4 1 by 6. This will be 4 2 by 6. 4 3 by 6. 4 4 by 6. 4 5 by 6. This is 4 5 by 6. And this will be 4 6 by 6. 4 6 by 6 means 4 6 by 6 means 4 plus 1 5. This will be 4 5 by 6 is, this will be 4 5 by 6. In classification of numbers, representing rational numbers on number line, and also I will show how to represent rational numbers on graph. Representing rational numbers on a number line. 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, and so on. You think that these are integers, but these are rational numbers. Really, they are real numbers. Afterwards, I will tell you how they are real numbers. Now, you see, these are rational numbers. If you see this one, these are integers, but these are rational numbers. You see, you take this here 1.5. 1.5 is between 1 and 2. 1.5 can be written as 15 by 10. 5 3s are 5 2s are 3 by 2. It is a rational number which is in the form of P by Q. Q is not equal to 0. 2 and 3 are integers. Therefore, 3 by 2 belong to rational number Q. Now, you see, you take here you take minus, this point will be minus 0.5. Minus 0.5 means 5 by 10. This can be written as 5 1s are 5 2s are is equal to minus 1 by 2. Minus 1 by 2 is a rational number. This is in the form of P by Q. Q is not equal to 0 and 2 is not equal to 0. Like this, these are all rational numbers. There are infinite rational numbers between 1 and 2, 2 and 3. Infinite rational numbers between 2 and 3. How? You see, between 2.1 and 2.2, 2.12, 2.13, 2.14. There are infinite rational numbers between 2.1 and 2.2. Like that, there are many rational numbers on this number line. Representing rational numbers on graph. See, usually we will take graph. This is x-axis. Horizontal line is called x-axis and vertical line is called y-axis. Many students think that we will take integers on graph, but we will take real numbers on the graph. I will show how to represent rational numbers on the graph. In graph, 1 centimeter is divided into 10 parts. Each part is 1 millimeter. Means if you take this point will be 2.1. This will be 2.2, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. This will be 2.9. There are many rational numbers between 2 and 3. 2 and 3, they are also rational numbers because 2 can be written in the form of 2 by 1. 3 can be written in the form of 3 by 1. They are rational numbers because they are in the form of P by Q. Q is not equal to 0. P and Q are integers. Like that, there are many rational numbers between 2 and 3. And also, if you take 2 and 2.1, 2 and 2.1, there are many infinite rational numbers between 2 and 2.1. How? 2.01, 2.02, 2.03, 2.04, like that. Many infinite rational numbers between 2 and 3. Like that, there are many rational numbers between 2 and 3. We will take real numbers on graph. These are all real numbers. All rational numbers are real numbers. I will explain what is a real number. Representing irrational numbers on number line or graph. See, irrational numbers, they are denoted by Q dash. See, real numbers, Q and Q dash together, we will get real numbers. I have already told you about rational numbers. Now irrational numbers. Root 2, root 3, root 5 and so on. These are irrational numbers. You see, if you take Pythagoras theorem, in Pythagoras theorem, if you take, this is a right angle triangle and this is 90 degrees. Opposite to 90 degrees is, this is hypotenuse. This is 1 unit and this is 1 unit. You have to find hypotenuse. See, if you take A, B, C, what is Pythagoras theorem? In a right angle triangle, square of the hypotenuse is equal to sum of the squares of other two sides. Means AC square is equal to AB square plus BC square. What is, we have to find AC. AC square is equal to, what is AB? AB is 1 unit, 1 square, plus what is BC? BC is also 1 unit. See, AC square is equal to, 1 square means 1, 1 square means 1. You will get AC square is equal to 1 plus 1, 2, and you will get AC is equal to root 2. This is an irrational number. I will show you how to represent irrational numbers on graph. How to represent irrational numbers on number line. What are irrational numbers? They are root 2, root 3, root 4 is not an irrational number. Root 4 can be written as plus or minus 2. Plus 2 is a rational number. It can be written as 2 by 1. And minus 2 is also a rational number. 2 is rational number. It can be written as 2 by 1. Minus 2 also a rational number. It can be written as minus 2 by 1. Like that, root 4 is not an irrational number. It is a rational number. Root 2, root 3, root 5, root 6, root 7. Root 9 is not irrational number. It is a rational number. Because it can be written as plus or minus 3, 3 by 1, minus 3 by 1. They are rational numbers. Root 8, root 10. These are all irrational numbers. How to represent irrational numbers on graph? See, this is 1 and this is 1 unit. If you join them, see, already I told you by Pythagoras theorem, this is 1 and this distance is 1. This will be 1 square plus 1 square means root 2. Measure this distance with the help of compass, and this will be, you see, this will be, you see this one, and this will be root 2. This distance is root 2. Again, how can you represent root 3 on number line? This is root 2 and this is 1. You join these two. We have to find how much. This is root 2 and this is 1. I will do here so that you can understand easily. This is 1 and this is root 2. Hypotenuse square. Square root of 1 square means 1 and root 2 square means 2. This will be root 3. Again, you measure the distance between these 2 points. These 2 points with the help of compass, and you do. This will be, this distance will be root 3. Again, join these 2 points. This will be, you observe, this distance is 1 and this distance is, already I told you this distance will be root 3. Hypotenuse you have to find out. Root of 1 square means 1. Root 3 square means 3. Root 4. Root 4 means 2. Like this you have to represent. Root 2, root 3, root 5 and root 6, root 7, all irrational numbers on number line like this. These are irrational numbers. Rational numbers and irrational numbers together called real numbers. Now we came to real numbers. Real numbers are represented by R. Now classification of numbers. Numbers are divided into 2 parts. Real numbers and complex numbers. Complex numbers are those root of minus 2. It is very difficult to find the value of root of minus 2. Root of minus 3. These are all root of minus 4. Root of minus 5. These are all complex numbers. It is very difficult to find the values. They are undefined. They are called imaginary numbers. These are imaginary numbers, complex numbers. They are imaginary numbers. Now real numbers. Real numbers means 0, 1, 2, 3, 4, 5, minus 1, minus 2. All these integers are real numbers. And also irrational numbers. Root 2, root 3, root 4, root 5. All these numbers are real numbers. And minus 0.5, minus 0.5, 0.5 and minus 0.5, minus 2.1, minus 3.5. All these rational numbers are also real numbers. Now real numbers are divided into two, rational numbers and irrational numbers. Already I told you, rational numbers and irrational numbers together, they are real numbers. Rational numbers which are in the form of p by q and q is not equal to 0. P, q are integers. Irrational numbers means root 2, root 3, root 5, root 6. These are irrational numbers. Now rational numbers 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. All integers are rational numbers because they can be written in the form of p by q. 2 by 1, 3 by 1, 4 by 1, minus 1 by 1, minus 2 by 1. They can be written in the form of p by q. Now, and also 0 is also a rational number. And also minus 1.5, 1.5, 2.1, 3 by 2, 2 by 3. All these are rational. 2 by 3, 3 by 2. All these are rational numbers. Rational numbers are again divided into two. They are integers and fractions. Integers. In integers 0, 1, 2, 3, minus 1, minus 2, minus 3. These are integers represented by z. Fraction 1 by 2 means 1 by 2 can be written as 0.5 decimal fractions. 1 by 2. 1 by 3, 2 by 3, minus 2 by 3, 29 by 6, all these numbers, minus 29 by 6, all these numbers are fractions. And also you will get decimal fraction also, you will get like 0.5, 0.25, 0.001, all these are fractions. They will come under decimal fractions. Next integers are divided into whole numbers and negative integers. What are whole numbers? 0, 0, 1, 2, 3, 4, 5 like this. These are whole numbers and represented by W. Next, remaining are integers. You see minus 1, minus 2. You see minus 1, minus 2, minus 3 like this. These are negative integers. Next, whole numbers again divided into 2. Whole numbers are divided into 2. They are natural numbers and 0. Whole numbers having 0 and natural numbers. They are represented like this, a number line, and 0. And natural numbers again divided into 2. They are even numbers and odd numbers. Even numbers are 2, 4, 6, 8. Odd numbers are 1, 3, 5 like this. Even numbers are completely divisible by 2. Odd numbers are not divisible by 2. I will give a note for you. Real numbers are divided into 2. They are rational and irrational numbers. Rational numbers are divided into integers and fractions. Integers and fractions. Integers again divided into whole numbers and negative integers. Whole numbers again divided into natural numbers and 0. Natural numbers are divided into even numbers and odd. Natural numbers and 0. Whole numbers. Whole numbers and negative integers. Integers. Integers and fractions. You will get rational numbers. Rational numbers and irrational numbers. You will get real numbers. And you see, natural number set is subset of whole numbers. Whole number subset of integers. Integers is the subset of rational numbers. Rational numbers is the subset of real numbers. We should remember this. All natural numbers are whole numbers. All whole numbers are integers. But all integers are not whole numbers. All integers are rational numbers. But all rational numbers are not integers. All rational numbers are real numbers. But all real numbers are not rational numbers. Up to 10th class we will have real numbers. After in intermediate and future mathematics you will get complex numbers. I think we have understood about real numbers.